Well, good morning, everyone. This is Penny from Wisconsin Land and Water, and thank you for joining us today for the Comprehensive Nutrient Management Plan CNMP Updates webinar. And I think that's about it. So I am going to turn it over to Scott Miller.
Wonderful, Penny. Thank you. This is Scott Miller, the Assistant State Engineer for NRCS in Madison. It's been a while since we have gathered and talked about CNMPs, and we have some new individuals, not quite new anymore. They've been here a while, but maybe new to some of you on the webinar today. Steve Becker is our state engineer, and you'll hear from him in a bit. And Eric Hurley is the state resource con, and we're going to head that direction now. So take it away, Eric.
Okay, and now bear with us as we deal with the technology here. I tell you, talking about CNMPs, talking about these issues into a screen in front of me is just doesn't feel right. So I do miss the interpersonal sort of things. Just to give a little bit of background about me, I actually am a native Iowan, though I have spent most of my professional career in Wisconsin. I'm a UW Stevens Point grad, and also studied agronomy, and that was in soil science, studied agronomy at Iowa State University. I taught nutrient management at North Central Technical College in Wausau, and worked as a nutrient management educator in Portage County and some other counties in central Wisconsin, doing soil conservation and nutrient management plans as a part of a CNMP. Then I worked prior to this job 9 years as a nutrient management specialist for NRCS in Iowa, and I've been the state resource conservationist here in Wisconsin for, I guess, 1.5 years now. So the next slide, please. So today we're going to talk about CNMPs, kind of give a broad overview, but then give a introduction to the new statement of work, which replaces the old job sheet for CNMP. We'll be talking about some other issues related to CNMPs, and hopefully give an introduction to what will happen in the next 2 sessions, where we'll get into some more details about planning the CNMP and then some specific issues with CNMPs that we see. This is not a full-scale course in CNMP, but hopefully we'll hit some highlights and build on the knowledge you already have. Before we get into that, though, I want to talk a little bit about some work that will impact you that's been done on the Field Office Technical Guide. Next slide, please. We've gone through some rework on section 4 of the Field Office Technical Guide. This is the section that contains our standards and various standard documents. Next. So what you will see now, if you go in there, you will actually see 2 sections that contain standards. So there is the old section 4, and I would encourage you not to use that. We will be removing it at some point. And then we've got the new section 4, or new part of section 4, which is the conservation standards and other documents. There's been a few things that have changed that I think you're going to find are helpful. One is that we've worked hard to, you can go to the next slide, to bring all the various standard documents together. So if you're going to deal, as in this example, with grass waterways, you're going to find most, if not all, of the documents that deal with grass waterways all in this section. This is not an absolute change. A lot of the engineering drawings and such that you're used to going to the website, they're still available there. There's another change which you might be surprised when you open up a standard, it will look different. And that's because we've ported all these standards over to so that they can be used by people with disabilities. The information in the standards is not different. It's just that it looks different. So now we're going to jump into the actual, CNMPs and what that looks like, and some of the information we want to provide. For me, it really helps to understand in the first place why we do CNMPs. And I think back to when I was doing nutrient management planning in central Wisconsin. The term CNMP was first introduced to me. I'd been doing nutrient management planning with farmers for several years when I came across this term. And so the next slide, I wanted to just talk a bit about why it is that we do this. Well, first answer comes to mind, well, NRCS requires it for financial assistance for manure pit, right? That's why we do the plan. Well, that's true, but it really does beg the question. Why did we come up with this, this concept of a comprehensive nutrient management plan? Next. Let's say we start with a farm, and like this one, it's an open lot. The manure is conveniently removed with each rain. Some of the manure at times ends up in a nearby creek. So we've got a potential water quality problem, right? This is one of the things when we're involved with this work we're trying to solve. Actually, it's not a potential. This is a water quality problem. These nutrients, the pathogens, they are ending up in that creek. The creek ends up with a reservoir, causes algal blooms, pathogens end up in city water supplies. Locally where you live, you know these problems better than I do. So what's the solution? Next. Well, there are many possible solutions to this scenario. In this case, they chose a monoslope building. They actually closed down the open lot. Maybe they put in a bedded pack in this building, or they have a separate waste storage structure that you're not seeing in this photo. But manure is no longer running off that open feedlot into a nearby creek. So the problem's solved, right? Well, no, at some point, that manure needs to be applied to the field. Just there's other steps that happen. But for this, yeah, the problem looks like it's solved. Next. We do CNMPs so that when we solve the manure runoff problem on the farmstead, we don't just transfer that problem to the cropland. By over-applying it in some places, or applying it in fields where it's going to easily run off, or applying it at times in fields where it's easily going to run off, this is why we do a CNMP. Now, to be clear, that's not the only purpose of a CNMP. It does go beyond that. There's a lot of reasons that CNMP is useful for a farmer to make decisions. If you're writing the CNMP, though, we need a practical product that can help the producer make a decision about how they're going to solve the problem on their farmstead and make sure that that problem is not just transferred when they apply that manure to the field. And added bonus, maximize the value of that manure as a nutrient product. So there's a lot of pieces to the CNMP. But I guess in the world according to Eric, this is the key, is we have this specialized plan so that when we solve a problem on the farmstead, we also solve the problem when we apply it to the field. Next. So the goal of the CNMP for an animal feeding operation for the owners and the operators is to minimize water and air pollutants from the storage facility and confinement areas and from the land application areas. So this is the key, and I've listed here the particular policies that define this. So this is kind of the primary goal. And next we'll get to the objectives of the CNMP. And that's to provide the owners and the operators a plan to manage the manure and organic byproducts by combining conservation practices, that's both on the farmstead and on the cropland or pasture areas, into a conservation system that will control soil erosion, protect water quality, and protect air quality. To me, this slide, this really is the essence of what a CNMP does for the producer. And you'll hear me say over and over, for the producer. One of the key parts when I was working with nutrient management planning and with CNMPs, I found that quite often by the time the CNMP was written, the producer didn't really understand what was in it. But, it's really important they understand how this plan will help them control soil erosion, water quality, and meet air quality goals. Next, the comprehensive, just kind of give you an overview of the nutrient management, the comprehensive nutrient management plan. It's for a standalone livestock production site. Sometimes the language has swithed. Production site it was common language used, and a lot of times you'll hear this when talking about CAFOs. We reference that as the farmstead in NRCS. It also includes the cropland, the pasture land, and other lands that receive mechanically the applied manure from the farming operation. It does not include satellite facilities, and this is a change. So in the past, satellite facilities would also be included in this plan. Now we're focusing on that farmstead operation and the land where that manure is going to be applied. The next slide. So what are the elements of a CNMP? The CNMP is really made up of 3 conservation plans. There is a 4th element, the signature page, kind of that grayed out because that's kind of goes without stating, but we have the conservation plan for the farmstead. This quite often includes waste management system of some sort. We have a conservation plan for the crop and pasture, the land treatment. So this is controlling erosion, making sure that we control both sheet and rill and ephemeral gully erosion. Then we have the nutrient management plan, and this is the 4 R's. And so this is how and when and where and how much and from what source the nutrients are going to be applied to the land. Next slide. So what is the development of the CNMP? The development of CNMP requires direct communication. Well, okay, in the development of the CNMP, it requires direct communication between and involvement of the producer, the technical service provider or consultant when contracted by the producer, and NRCS staff and conservation partners. I think you'll hear throughout from this discussion today that communication at all points is really going to be important for the CNMP to work. This does take work on for all parts, and you'll see that we've actually built this in to the statement of work. Next. There are several steps to the conservation, or to CNMP on conservation planning. And we talk often within NRCS and among the partners about the 9 steps of conservation planning. The CNMP will take us through 7 of those steps. Kind of group these into a couple of major areas, and what I call understanding the problems and opportunities, or understanding the resource concerns. We need to identify those problems and opportunities, determine the producer's objectives, what it is that they want to accomplish on the land that we're dealing with, inventory those resources, and analyze resource data. I'll be talking more about some of these issues in later slides, but also in the next session, we'll get into this in more detail. The second part is understanding solutions. So what are the conservation practices that we're going to include in this plan? We need to formulate alternatives, and hopefully part of that discussion is more than one alternative. Often we come in, well, we just want to build a waste storage facility of some sort. There may be other alternatives, so those should be considered as part of the planning. Evaluate whether those alternatives will actually meet the needs of, meet the resource concerns and meet the objectives of the producer. And then the final step is to make a decision about what conservation practices would be applied. And these are all covered in the National Planning Procedures Handbook. And again, more details about this will be discussed next week. So the beginning steps is identifying those resource concerns. And remember, the CNMP goals and objectives are to address soil erosion, water quality, and air quality. So the first piece of that next is soil. We've divided this into several different pieces. It's up. It's a little bit of delay, so sometimes I get behind on the slides. And I'll discuss each of these in detail, but we have sheet and rill erosion, wind erosion, ephemeral gully erosion, classic gully erosion, and bank erosion from streams, shorelines, or water conveyance channels related to the livestock use areas. So the next slide, I'm going to walk through each of these. Sheet and rill erosion, this is kind of the, this has often been one of the most important pieces of erosion, especially in impacting productivity of the land. But it's also the beginning point at which particles and phosphorus are removed from the land and may end up in streams. So what sheet and rill erosion is, it's initiated by raindrops, and then as water flows over the soil, it will carry those particles with phosphorus, and if it's manure particles, it might contain pathogens and such. Rills is where that water begins to concentrate someplace on the slope. So that's the beginning. And what you see in this slide, I'll get to where you can really see the water flowing in a second, but for most of the slide, you are seeing that sheet rill erosion and in action as it moves soil off the field where it's needed for productivity and moves it into areas where it's not going to have production. In Wisconsin, most commonly we use SNAP Plus to estimate this, but this is also something you should be observing in the field and talking to the producer about to see if the producer observes that this is happening in some of their fields. Just another program to mention is Russell 2, which is actually embedded in SNAP Plus. So that's the revised universal soil loss equation. The next step is, and I'm going to reuse one of the photographs here, is ephemeral gully erosion. So this is where those rills, that concentrated flow, concentrates to a point, and it always concentrates in the same place, storm after storm. And you start seeing, as you can see in both of these photographs, and the one on the left, you see the aftermath of a rill in the field. Quite often it erodes all the way down to some more stable layer. In most of the fields that I've worked with, it's been the plow pan, because we've had those sorts of issues that erodes down to. Again, that photograph on the right, I guess Scott has a pointer. He can point to the point where the rills become an ephemeral gully, and that's where you see the water flowing there. Ephemeral gullies leave a mark on the field, but equipment can still get through that, as opposed to gullies, which we'll get to in a second. And they can go through, and I got to do a pair of air quotes. I guess you can see me. The equipment, you can till it in, you can heal that ephemeral gully, which means that you drag in good soil, which the next rain washes away. So ephemeral gullies can be really important part of the erosion and the delivery of phosphorus into our waters. I guess I have a bit of a pet peeve about this issue, because quite often it's one that we ignore. We can spot it on aerial photos, and so that's one way you can see if it's there. You can see it in fields, but sometimes at certain times of year you won't see it. Or you can talk with producers about if they experience these ephemeral gullies. They're an important part of that delivery process of phosphorus. So I'll get back to these issues, but I just wanted to take a side note. One of the parts of the conservation planning process is you're going to be doing a site visit. And I'm showing these photos because these are things that you need to be looking for. You need to be taking notes about what you see, document existing conditions with photos that can be really useful for later, can be part of the conservation plan. Can document if existing conservation practices are working or not. You will need to, often I don't have it on here, but sometimes you can't see these problems. You need to be talking with the producer to see, ask them questions to see if they have those problems. Next slide. Just wanted to show you some additional sides of ephemeral gullies, the sorts of things that you will see out in a field situation. Next. This is classic gullies, and I couldn't resist pulling a slide from the Coon Creek watershed from the 1930s. And of course, we think about these well, canyons that formed back then, and you know, were obviously detrimental to the farm. Now, what you see on the right is more likely of what you're going to run into. Although I've seen some gullies where I could get down in them and they were deeper than I am tall. So, but usually you'll see these classic gullies like you have on the right, something that is going to be disruptive of a producer, is easy to spot in the field. And usually there's a lot of motivation to solve these problems. Next, I'm going to talk about wind erosion a bit. These are actually two slides that I took when I worked in central Wisconsin. So this is from actually probably a couple decades ago, starting to age myself here. What you're seeing in the lower right is you can see the fine sediments are moving, and these are high in phosphorus. So they can be critical the delivery of phosphorus and should be something that you consider. And then what you're seeing on the upper left is actually, well, this is my Iowa language that I'm not sure it's used a lot here, snert. So that's you know, the soil mixed with snow in a drainage ditch. And again, as you can imagine, when that melts, those particles will, with the next rain, they'll end up going down that creek and ending up in a flowage downstream in this particular case. So this can be an important delivery way and needs to be evaluated and inventoried and evaluated. Stream bank erosion is another piece of this. I've rarely seen where this has become an issue in CNMPs, especially on cropland, but it's something that you should pay attention to if it's there. Most likely this is going to be an issue that you might see cutting into where feedlot is at. Keep your eyes open. Oh, and I was reminded, I don't know if you could hear that, it can be an issue if it's cattle induced. So they have access to the creek and they can cause some of that stream bank erosion. So that's another issue that need to keep your eyes open for. So we've been looking at these erosion problems. So what happens next? Frankly, when I first got involved with sheet and rill erosion and dealing with that, we were always focused on maintaining the productivity of that field. We want to keep those sediments in place to do that. That's important. But those sediments leave the field. So that leads us to the next set of resource concerns that we're going to need to deal with. And that's when these sediments get to the water and they carry with them nutrients. In the case of surface waters, quite often dealing with phosphorus is one of the most common. Although it could be ammonium. I've seen where that's been an issue with fresh, or I should say with swine manure applied to a field and runoff. Nutrients can be transported to groundwater, and quite often the big discussion there would be nitrates, pathogens and chemicals to surface and to groundwater. And again, we deal mostly with the runoff issue in the CNMP. That's primarily what we're dealing with on these issues, but also potentially be transported to groundwater, especially as we see water flowing through inlets and so in the soil. And then the sediment transported to surface water. So these are all pieces, and I'll just show you some, well, the next slide, show you some of the impacts of that. Again, you're probably aware of these more than I am locally. Particular lakes you can think about, and you know, what you see in those lakes are flowages, some streams. In the top photo here, you're seeing a fish kill. This was from ammonium. This is actually not from a field spread manure. This was actually a spill, but it can happen when manure is applied to a field and it runs off quickly, especially high ammonium manures like swine manure. In the lower left, you're dealing with phosphorus entering a lake and causing an algal bloom. Algae dies, and all the oxygen is used up, fish die. In the lower right, you're seeing where a particular type of bloom occurs, which produces toxicity and can poison drinking water, as happened in Toledo, Ohio, about 4 years ago, where they lost their water to just such an algal bloom. Now, you look at this, go back there, you look at these problems. These are not problems that we're solving directly. We don't go in and aerate the waters or something. Our role in this is to prevent things from getting to that water that cause this. And this is part of conservation planning. So our work that we just talked about before that's happening in the field is preventing this. And that's where the resource concern comes into play. We use SNAP Plus, which embeds the Wisconsin Phosphorus Index into it to estimate the delivery of sediments and phosphorus. And this is one of our primary tools for doing this. Next slide. This piece, and I'm not going to sign on this, is air quality. We deal with objectionable odors and emissions of particulate matter or particulate matter precursors, as the case may be. We'll be assessing air quality tool. It's required for operations with greater than 300 animal units, and it's encouraged but not required if there are less than 300 animal units. Next. Now, there are some things that, I've been using some pretty precise language on what is a resource concern. And there's some things that are not resource concerns, although they may be concerns for the producer as a part of this plan. So not to be ignored, but they're not a part of the planning process and would not, we would not use them to designate that. So manure is not a resource concern. Cattle and mud, very much a concern of people, but is not a resource concern. Winter spreading in and of itself, if it follows the nutrient management standard, is not a resource concern. However, winter spreading always has issues with it. So, it can be part of the planning process. Next week, we will cover the planning criteria for these resource concerns in more detail. So stay tuned for that. Then we'll talk a little bit about who does the CNMP, and there are different people that can become involved in the process. A certified CNMP planner or a TSP would be doing the nutrient management part of the plan and other elements and bringing the plan together. This point, though, I'm going to turn it over to Steve, our engineer, to talk about engineering and get into talking about the new statement of work.
All right, thanks, Eric. So my name is Steve Becker. I'm the state conservation engineer. I'm responsible for the design and construction of conservation works of improvement for NRCS in Wisconsin. I got a bachelor's and a master's degree in agricultural engineering from the University of Minnesota. I spent 2 years as a project engineer on the South Zumbro flood control project near Rochester. I was an area engineer for NRCS near Mankato, Minnesota for 14 years. And then my family and I moved to Bozeman, Montana, and I was a state conservation engineer in Montana for the past 14 years. So I've been the state engineer in Wisconsin since last April of 2019. And I've enjoyed the experience so far. And I'm here today to talk about primarily part 2 of the CNMP, which is the farmstead planning. So I guess this is a good introductory slide to start with. You know, who prepares the CNMP, or who is the writer of the CNMP? And it's basically 3 parties. It's the Certified Nutrient Management Planner, or the TSP. Secondly, it's the professional engineer. And thirdly, it's the landowner or operator. So just as kind of a side note, NRCS has determined, that the evaluation of existing waste storage and handling structures, the formation of alternatives, and the interpretation of technical criteria in the NRCS standards does constitute the practice of engineering. And this slide kind of has a reference in that regard. The question comes up, a fair number of times, is a PE stamp or certification on these plans necessary? And NRCS does feel it is necessary. So as I mentioned before, the 3 parties for to write a CNMP are the CNMP planner, the PE, and of course the owner and operator. And on the signature page of the CNMP, there's 4 parts, and that's one of them, is that signature page. There's basically a certification statement on there that these 3 parties agree to prepare this document in such a way and format that it meets NRCS criteria. So this is just that certification statement that the owner would be attesting to. So I think in the past, these comprehensive nutrient management plans, or these CNMPs, the requirements, the deliverables for those were in what we call a job sheet. And we've kind of changed the terminology for that. And so we wanted to get you familiar with the new verbiage. We basically call them statements of work. So the required information or deliverables for a CNMP is now shown in what we call a statement of work. So you can find those statement of work or the requirements for CNMP in our field office tech guide, section 3, under the CNMP subsection. And in there, you can see toward on the right side of the document here, you can see there's a CNMP overview PDF, there's the signature page, and then there is the statements of work that basically lay out the requirements for the documentation, formatting, and information in the CNMP. As Eric mentioned, it's probably a good time to kind of regroup on this. The CNMP is divided into a pre-planning meeting and 4 basic parts. Required plan information, the templates, and the work for each of these parts are found in section 3 of the field office tech guide. So once again, it's the pre-planning meeting, signature page, farmstead planning portion, the land treatment portion, and the nutrient management portion. So we'll kind of work our way through each of those parts with a little bit of a slant on the engineering, of course, because I'm in the primarily talking about the farmstead planning portion. This pre-planning meeting, I think, is pretty important. I'm sure the TSPs and the PEs out there, they don't really want to waste any time, and we want to kind of prevent this iterative back and forth between the NRCS reviewers and the CNMP planners. So I think it's pretty important to have this pre-planning meeting between the owner and the operator, the CNMP planners, and NRCS. It's a nice way to ensure that the owner or the operator, that their needs and objectives are heard. You know, they usually have some idea of what they want for waste storage, handling, and land application. It's important that they're heard. This pre-planning meeting is a nice way to document that. The meeting is also an opportunity to kind of affirm what production areas, facilities, and features need to be inventoried out there so that there's no disagreement or some one feature facility on the property may seem to be of higher value to NRCS than maybe the planner, or vice versa. This is kind of a chance to get on the same page. We can be a little more articulate on what facilities need groundwater, surface water, and air quality assessments. We can identify what existing structures need a competency evaluation and discuss the level of investigation to determine whether some of these structures are basically competent. And you can discuss what information may have been collected by NRCS or others. The CNMP planner or the PE may not have been the first party out on the site helping the landowner make some decisions with regard to waste storage and handling. NRCS works with a lot of partners, county staffs, and for example, and it's just an opportunity to kind of call out what's already been done and share that information. NRCS may have came out on a previous occasion and did some backhoe pits or borings. It's nice to know whether that information is available. County staff may have came out and did some site-specific survey. They might have some value to you. So the signature page is pretty straightforward. I've already flashed up on the screen kind of what those certification statements look like. So by signing, as each of these parties sign that signature page, they're attesting to the fact, they're certifying to the fact that the resources and the facilities were properly inventoried, and alternatives were formulated and well documented, and you've basically followed this CNMP template. So part 2 of the CNMP is the farmstead planning, and there's a lot of subsections under farmstead planning. So I'll just kind of lay those out right away. There's, as you would expect, the farmstead overview, pull in photographs and maps, doing kind of the inventory work, analyzing the resource data, which is basically doing the assessments for groundwater, surface water, and air quality pollution, evaluating the integrity of existing waste storage and handling structures that are out there that may be used in the final plan, calculations for the waste stream, and basically a summary of the resource concerns that are out there with regard to groundwater, surface water, and air quality. The farmstead planning also includes the formulation and evaluation of alternatives, and then a record of decision. What's currently applied will be what structures will be used in the final plan, what the plan practices are, and kind of what the estimated implementation schedule is, and as far as putting this plan into action. So I'll kind of go through each of those subsections under farmstead planning in a little more detail. as mentioned before, the farmstead overview is pretty straightforward. It's just a brief narrative description of the animal feeding operation, which is the number of animals, the timing that they're on the lots. If they're outdoor lots, you know, when you're looking at manure production, you need the weights of those animals. Basically, you follow the waste stream and describe it from where the waste is generated, how it's transported, collected, and handled. So the farmstead overview also has, you know, it would include labeled site maps with existing buildings, the location of wells and domestic septic systems, because they all have setbacks, right? Existing practices and features on a photo background. Would also include any on-the-ground site photographs of inventoried features. And then lastly, it's kind of mentioned before in the pre-planning meeting, you know, if there are some engineering designs, construction drawings, O&M agreements for existing practices that are out there, we'd want to kind of pull those together, aggregate those, and put those under the farmstead overview. Inventorying the resources. So, like I said, during the pre-planning meeting, this statement of work will be brought to that meeting by NRCS, and it's an opportunity at that pre-planning meeting to kind of customize a statement of work a little bit. You know, each of these farm sites are a little different. They all have different types of animals, animal numbers, combinations of indoor and outdoor confinement, different types of storage, stacking areas, and waste treatment systems. So it can be a lot to inventory. So that pre-planning meeting is pretty important, and it gives NRCS a chance to kind of go through and check these boxes, and basically work with the planners to affirm what items need to be inventoried and what doesn't. There also might be a little uncertainty in what's considered a satellite facility. Sometimes, you know, there's an open lot or buildings that are 300 yards away or 100 yards away. You know, what constitutes a satellite lot, what doesn't. Some of those discussions can take place during the pre-planning meeting and the affirmation of what resources should be inventoried. I'm sure a lot of the CNMP planners and Ps are very familiar with what needs to be inventoried. So a lot of people feel like they should have a check mark on everything. But I think you can interpret this as just being kind of an affirmation that NRCS, the planner, and the landowner are kind of in agreement on what facilities are going to be inventoried. If there's any biosecurity measures, that's a nice time during the pre-planning meeting to discuss those also, and let the landowner know that the CNMP planners of the P needs certain types of access to certain areas to conduct this inventory. The farmstead planning component also includes these assessments that need to be done for groundwater, surface water, and air quality. So in section 3 of our field office tech guide, there are quite a few templates in there to make this job easier for you. You can use those templates or not use those templates, but they can be pretty handy. Sometimes they're called tools, sometimes they're called worksheets, sometimes they're called templates, but basically it's found in the CNMP folder in section 3 of the field office tech guide, and you can scan through them and use them, download them and modify them to fit the formatting of your company or whatever. So just want you to be aware that they're available. I want to mention a couple of things in red. This is largely an assessment of existing waste storage and handling facilities. So, you know, we're kind of evaluating the pollution risk from existing waste storage ponds and tanks, pumps and pipelines, feed bunkers, manure stacking slabs, vegetated treatment areas, right? And so we have tools like the BERT tool to assess surface water pollution potential. We have some templates, as I mentioned before, to help you assess the groundwater pollution contamination potential from things like a feed bunk. So I wanted to mention a couple of things here at the bottom in red, and that is, in order to do a good job with your groundwater and surface water assessments for pollution, you generally need to know something about the soil. So if there's surface water runoff from these waste storage facilities, eventually that surface water runoff passes across some soils and through some buffer areas on its way to waters of concern or state waters. So you will need to identify the soil map units in the web soil survey to kind of describe the soils that surface water is going to be running across. Makes a big difference whether that surface water is running across sand and gravel pit or whether it's running across clay on its way through a buffer system to state water. So secondly, when you're looking at groundwater pollution potential, so if you have, say, a manure stacking area with a concrete bottom and it's cracked up, and you kind of wonder whether that leachate has a potential to pollute groundwater, you know, you can go through our template checklist, but, you know, it's largely going to be based on what kind of soils are underneath that facility. So you can anticipate and need to be aware that you're going to need to drill some test holes. But for these assessments, we're talking about, you know, 2 to 5 foot test holes that can be dug with a we call a back saver, soil sampler, or a bucket auger. But the things that we're looking for are pretty obvious. You know, separation to the seasonal high water table or an area of saturated soil zone, separation to bedrock. And then we're also trying to qualify that soil a little bit by running a couple of basic index tests for the soil permeability. And we usually look at the percent fines and the Atterberg limits of that soil. So be aware that there's a certain amount of soils investigation that is required to do a good job of assessing the pollution potential from some of these existing facilities. Also under the farmstead planning section, and this is pretty important, it's the evaluation of existing structures. And once again, the pre-planning meeting with NRCS staff is pretty important on this issue. Almost all these facilities all these farm operations that you'll be visiting, they usually have some existing structures out there, whether it's a reception tank or an old waste storage pond or a feed bunker, something like that. We need to have an engineer take a look at those facilities, and if they're going to be utilized in the final plan, if they're not going to be decommissioned, you know, we want those evaluated. We want to know, you know, whether they're competent structures to continue to serve its purpose in the future. So this is kind of a big subject because depending on the farmstead that you're on, you know, there's all kinds of different type of structures that people store waste in, everything from steel tanks to concrete tanks, below ground tanks, above ground tanks, different sizes. Some have reinforced concrete, some don't. So we're just looking for a good evaluation of whether those structures are basically watertight and whether they reside in a competent foundation. In other words, identify whether they're going to be a groundwater pollution problem. So we tend to investigate those structures with about the same level of intensity that we would if we were designing a new structure. And in the bottom there in red, you'll say, I did put a note there, we tend to apply the same level of investigation. Well, you know, if we were planning a new pond, you know, we'd take 4 to 6 soil borings around the perimeter. Well, some of these facilities are locked in with buildings around them. You can't get in and around these structures to get, you know, to define the soils around the entire perimeter. So basically you kind of do the best you can. So it's important that the PE and the NRCS and area engineer discuss this level of investigation a little bit. How many test holes are reasonable? How deep they should go? What kind of lab tests might be associated with those? Some of these concrete reception tanks are going to have manure in them, but we need to have those investigated. So you're going to have to time your investigation a little bit with the landowner or the operator to draw that waste out of there and get in there with some type of a mirror or power wash it or use a probe rod basically, and you're looking for like differential cracks or cracks, excessive cracking, you know, crack widths of a 1/16 inch or more. Basically that would lead you to believe that that tank or structure needs to be either repaired or lined or replaced. So this is an evaluation. It's not necessarily determination of what has to be done in the final analysis, but we do need a good evaluation and a good recommendation. Some of these facilities are just beyond their service life, and they need to be decommissioned. And NRCS does have cost share to decommission these structures and abandon them. In other cases, they just need to be patched. There's good epoxies out there, good concrete repair products out there that make that possible. And in some cases, the structures are patched, but they're in a very good soil unit. I mean, they're in a glacial till that just has a low permeability to start with. And so the integrity of the concrete just isn't that important. So you can see there's quite a few issues associated with evaluating existing structures. Good communication with the area engineer is important. And NRCS does have 2 payment rates for CNMPs, one with minimal engineering and one with basically a high level of PE involvement. And so if there's structures out there that need evaluation, we're generally paying at the higher rate. Lastly, in this farmstead planning section, you know, we do need to quantify the waste stream in terms of volume and flow rates. And so that's a big part of it. And then step 4 here under this section is just summarizing the resource concern. You know, we're running all of those assessment tools for surface water and groundwater and air quality. You need to kind of pull those resource concerns together and summarize them. Now, some people would say, I want to just make a mention of air quality. You know, Wisconsin doesn't necessarily have big open feedlots like Nebraska, for example, where, you know, dust and particulates, wind blowing dust and particulates off these feedlots are, you know, a big air quality problem. Like California, they have issues with that also. However, we do have air quality concerns on some of our facilities, and we do have conservation practices to address those. A lot of it is associated with odors, right? Hydrogen sulfide, for example, but we do have practices like biofilters and covers that we can put over these facilities to not only reduce greenhouse gases, but control odors. So air quality assessments are, I don't want you to underestimate their value, and I don't want you to feel like even if you did assess them, there's nothing we can do about it, because we can in some cases. So we can also make good decisions in planning. So if your facility has, say, swine, for example, and you have an opportunity to make a choice between putting that in an open pond where it's constantly open to the atmosphere and the wind that can blow those odors and create air quality problems to your neighbor, or put those into a covered concrete tank. And if those are ventilated, we could run that ventilation through a biofilter. Those are decisions that can be made if you've detected an air quality problem during the assessments. So the other part, or several parts under the planning, farmstead planning, it's the formulation and evaluation of alternatives. So at this point, you've inventoried the facilities, the waste streams, the number and types of animals. You've done the groundwater, surface water, and air quality assessments. And now it's time to decide how to pull all this together into a system that works for the farmer and addresses the resource concerns down the road. So what types of additional waste storage and handling systems are needed? So, you know, this is the place where the planner and the engineer kind of work together to pull together a system that may incorporate what's already being used out there. It may include the closure or decommissioning of existing structures, and it obviously will include, you know, new features, planning of new features. And so these are some of the formulating and evaluating alternatives. I will mention in bottom in red, in the past, NRCS was requiring the PEs to do a high level of soils investigations to plan new waste storage structures. What we found is usually when the implementation team picks up where the CNMP leave, after the CNMP is completed, at some point you're going to implement that plan. And when the design team picks that up, it seems like more often than not, a lot of that soils investigation, you know, wasn't deep enough, extensive enough. There wasn't an adequate amount of lab testing done. And so then we ended up having to go back out there again, get the owner to hire, you know, an excavation service or a geotech company to go out and drill again. And so we are not requiring that any longer. There is a certain amount of soils investigation, low level, required to do those pollution assessments. So don't get me wrong, you still have to look at the web soil survey and do some bucket auger testing. But as far as backhoe pits down to, you know, 20 feet around the perimeter of proposed structures, we're not requiring that at this point in time. That's more in the implementation phase. But we are asking you to be judicious about it, use the resources that you have. If existing borings were done out there, use them. Otherwise, use the web soil survey. Make the best landscape assessments possible to decide, to make decisions whether you want to go with above ground tanks or below ground tanks, and maybe what parts of the farmstead would be best suited for siting waste storage facilities. So anyways, I want you to take note of that highlighted red statement at the bottom. And then lastly, it's the make decision step. We want the CNMP to be a record of decisions. So you've done the inventory at this point, you've done the assessments for groundwater, surface water, air quality, pollution. You've evaluated the existing structures out there, and you've formulated some alternatives, and now it's time to kind of pull all that together, talk with the owner, and basically map out or sketch out the final decisions, and kind of bring those to the forefront of the CNMP plan, so that either you or a design firm or NRCS will be able to take the CNMP and implement it. And I believe that's all I have, and I'm going to turn it back over to Eric for part 3 of the CNMP, which is the land treatment portion.
There we go. So we're back to crop and pasture land. So again, the statement of work is listing the elements that are going to be needed to demonstrate that the conservation planning has been done, and documenting the 7 steps that we're talking about here are completed. So the piece here on this part of the statement of work is really documenting about the inventory of resources. So this is the results of the interview that you had with the producer. You can see there in the crop and pasture overview, talking about the crop rotation, tillage, manure application, existing conservation practice. Well, just those pieces, if you're running SNAP Plus, the sort of information that you're going to have to collect. So we need to make sure that that is collected and done. And if you're like me when I was doing that, there always seemed to be one question that I didn't get done, and I'm working in SNAP Plus and have to go back. So we need to make sure that is documented, and also for similar for pastures as it would be for cropland. The inventory can include a lot of different types of information. It can be narrative, it could be on maps. I tended to collect a lot of aerial photos and maps beforehand. Now, if LiDAR didn't have those back in the day, I would keep track of the soils and such to guide me as I did a walkover of the site. Made general observations about what I saw there, residues, crops were planted, any specific erosional features that I saw, water features. I quite often pulled those off the aerial photos. If there was things with that water was flowing through, I'd look for manure flowing across. It was a field that would always be a red flag or something to be looking for. The pathway from an existing feedlot or such. So this information would need to be collected and becomes a part of the plan. Next. So just a continuation of that. Again, your pasture evaluation notes similar to what you would have for your crop land evaluation. The next step, B, there is to analyze, the resource data. So this would be, how to analyze that the resource concerns and that data to make sure that, or to determine whether there's a resource concern there. A lot of that work we do within SNAP Plus, but there are other pieces. A lot of that will be discussed again next week. That's an important part of this because we need to determine if there's an impact. Is water quality being impacted? Is erosion occurring? So this is a part of that analysis. And then C there, we need to formulate alternatives. So we need to look at, how are we going to solve the problems that we've identified through the inventory and through the analysis of that inventory? What practices are available? And there's a tendency that I think a lot of us have who work in this area to jump to a specific solution. And I think it's important that we always reference back, what are the objectives, what are the capabilities of the owner or operator of this as we look at those formulations. One of the things that I always had as kind of an acid test in my relationship with the producer on these, if there was some point where we might discuss some totally different system. If they're focused on some sort of waste storage structure, well, maybe a grazing system would be an alternative. At some point in the conversation, we look at other opportunities that are out there, other alternatives, and this is the point to do that. Then we need to evaluate whether those alternatives meet those resource concerns, whether they protect the soil, they protect the water quality, and that they meet the objectives of the producers, and that would be documented. This points to the documentation for that. Finally, the next slide is the making of decisions, and I'm going to get into, I'm going to circle around back to these last couple pieces here because we've got some tables to document that these pieces are done. But making decisions, that's of course where the rubber meets the road. That's the decision the producer makes and that will solve and would be needing to document. This is not really different, but you'll see we've got some specific forms for that. Part 4, next slide, is the nutrient management plan. And this again has not changed much. We won't see many changes. It basically meets the nutrient management or 590 standard. The one thing that I would you think about, this is not just a theoretical exercise. This is not, can we make this work? It really has to be something that the producer can make work. That it's something that meets the capabilities of the producers, or if there's things that they need to learn, that needs to be part of the discussion here. So it's not just theoretically can this be done, but practically this is how it will happen. And I think that's an important piece of that. I've seen a lot of nutrient management plans that involved a piece of equipment that the producer didn't even have and had no access to. So just those sorts of things need to be a part of this, that this has to be a practical thing. Again, it goes back to that communication that we've emphasized throughout this. Next, though, we've got, this is getting into some of these tables that we have to document some of the pieces I just discussed. So we've got a table here for the inventory and analysis, or inventory and to analyze the resource concerns. So this goes through piece by piece of this documenting that this analysis was done. So let's just take, for example, go to the next slide. If we've looked at a field and we saw ephemeral gullies out there, that's part of that's planter inventory and evaluation. That we see these ephemeral gullies out there. If you go to the next slide, if we've seen that, then we have to make sure that that is documented in here, that was done. You'll see in some of these tables that there's an analog here to what was done in the past. And I guess I haven't talked about that, but of doing the environmental evaluation, commonly called the CPA 52. A lot of this information is that sort of thing. That is not something that TSPs will be doing anymore. So, but we're collecting the data so that we can so NRCS can do that. So that's where this information comes in. Next slide. Again, so this last piece, or no, it isn't the last one. This just shows some of the additional resource concerns that you would have with water quality in this sense. Wanted to point out to the third column there that a lot of this information does come out of SNAP Plus. It's modeled. Some of the others, though, would be done by the producer or by the planner. So it's part of that inventory and evaluation. And take just a a little bit of a step back on some as I go through this. We do have a lot of tools that we use. We require specific inventory and observations be done by the planner. It's really important to not just rely on those tools. They are important tools and they work really well. Snap Plus, which has Russell 2 embedded in it, has the Wisconsin Phosphorus Index embedded in it. They are important, but always keep your eyes open and don't check your brain out. You know, when you go to the site, you'll keep your observations free to see what's actually happening out there. And that we always emphasize, you know, the planner inventory and evaluation. So you need to be looking at these issues. Where is soil erosion happening? Maybe it's not caught in some other way. Look for those things. Look for the water quality issues that are important, you know, and they may, you know, well, they usually often aren't on the farm, but are maybe downstream, and that becomes part of the discussion. So always, you know, you're trying to observe, you're asking questions, and this plan is about solving problems, and always keep that in mind, even as we go through each of these steps where we're documenting this. The next piece of the CNMP statement of work is a record of existing practices. So when you're out there observing a site, a field, maybe there's a grass waterway through that field that has solved what otherwise would have been an ephemeral gully erosion problem. That needs to be documented, that's there. Please note that those, it can't just be some grass down field. I've seen grass waterways that have nice little ephemeral gullies running along the edge of the grass down both sides. They have to be functional. So that has to be part of the inventory, that those practices are still functional. But they have to be recorded here. If they're an important part of the CNMP, the CNMP would not function without those conservation practices being there, then existing practices need to be documented here. The next piece is where you would be recording planned practices. So this is kind of the meat. This is what's going to happen. This is what's going to be done. And so this is where you would identify the fields and the practices, you know, how much is going to be done. You know, use that grass waterway or cover crops or whatever practice is necessary to make this CNMP work, whether it's on the farmstead or on the cropland or in the pasture land or any land use that you have. So this is what the producer is agreeing to do as part of the CNMP. Next. Just a little side note to this. I mentioned about, you know, existing practices needing to meet the standards or still be functional and solving the problem that they were designed to solve. And I'll use a different example because I've seen this so many times where I've seen a buffer strip along a creek, but then to see the water concentrated flow is going right through it. So, you know, those sorts of things. Any conservation practice that's important to this plan really does need to meet NRCS standards, whether that's existing or what's being planned. Kind of to circle back, talking about the CNMP, the whole structure of the CNMP. You know, we've got this, you know, comprehensive nutrient management plan really consists of the 3 conservation plans: the farmstead piece, the piece where we do the crop and pasture land, and this is the land treatment. This is the conservation plan. It's making sure there's no sheet and rill erosion, ephemeral gully erosion, those sorts of things. Looking at setback areas from waters and so on. That's part of that crop and pasture plan, or it goes into the nutrient management plan. The third part is that it's a nutrient management plan. But these plans are not independent. These plans do talk to each other. So that if there are different people doing these pieces, they need to be talking to each other. And so the next slide, I tried to outline at least some of the issues that I saw where they do talk to each other. So the farmstead plan tells the cropland and nutrient management plans how much manure and nutrients will be applied. So the nutrient management plan, the cropland, they're going to be looking for the acres out there. So that how much manure is going to drive the acreage that really needs to be planned there. They're going to the farmstead plan will tell the other plans the type of manure and the plant availability of those manures. The type of manure in turn informs the placement of the manure. And somehow in there, oh yeah, and the final point is that the farmstead plan will say when the nutrients are available. So that's information that the nutrient management planner is going to need, that the cropland, who's ever doing the plan on the cropland or pasture land is going to need that information. It also works the other way, back the other way. So the cropland and nutrient management plans, and I left out pasture, that's a part of it, tells the farmstead plan how many nutrients can be applied to the land. Now, if there's only a limited land base, that answer could limit the number of livestock that can be a part of the farmstead plan. Again, this can be iterative because then it can go back and say, well, then we need to find more land. And that can be part of the planning process. When manure can be applied, the plan will tell when the manure can be applied to fields during the year and through the rotation. This in turn can drive the type and amount of storage needed. And I've seen this directly in a plan where at some point there simply weren't fields available. Overall, theoretically, there was enough land that could receive that manure, but as the rotations played out, there was a choke point. And that's part of the discussion here, is to check, to make sure that there aren't choke points. So we plan to apply that manure. You don't plan an emergency, you plan everything out. So that's a communication that needs to go from the cropland system, the nutrient management system, back to the farmstead system. Again, it could change the numbers, it could change, the case that I'm thinking about, the person decided to take part of their livestock and move it to another farm during that particular part, the rotation. So there are alternatives that can happen, but that's part of the communication that needs to happen. Implementation requirements is another piece of nutrient management plan. And in the past, there's been some discussions and variations on what's required to implement the plan. Implementation requirements will have to be developed. Sometimes they have different names, sometimes they're called job sheets. There's some nomenclature changes happening in our agency, and all they can do is say it's happening and apologize for changing the language. Plans and specifications is quite often terminology used among engineers, and that will stay consistent. These will need to be developed, but they are not required to be part of the CNMP. However, an EQIP application, including the implementation requirements, will improve the likelihood, well, I should say in an EQIP application that includes implementation requirements, that will improve the likelihood that it is funded. And the reason for that is because then things can happen more quickly. So there is a little bit of a flex here, but the CNMP itself is going to tell you what practices are going to be implemented, but not necessarily fill out the job sheets, which takes that practice to the field level. That's what the implementation requirements do. They say this is what happens on this field specifically. And now the exception to this is nutrient management, because essentially part 4 of the CNMP is the implementation requirements for the nutrient management. So that is the exception to this guidance. Just wanted to introduce, because I know there'll be some questions about certification and who's doing this. We talked about earlier, or Steve did, about who the writer is and such. Just wanted to throw this up. That there are some requirements to be a CNMP planner, and individuals must be either existing NRCS or partner employee. Part of private sector, we've got the TSP system. We can't have volunteers involved with this. This is outlined, and we'll be discussing this more in the third session. So we'll have more details on this, especially having to do with the TSPs, because there'll be some questions about that. And that's what I have about conservation planning and the new statement of work.
We have gotten some questions along the way here. First one is a little bit of a definition of satellite farms. Does anybody want to take that? If not, I'd be glad to. So satellite farms are an interesting thing in Wisconsin, right? There's the property right next door, contiguous with the farmstead, we're moving over to a brown, field site. That's the farmstead. That's where we're at. We're talking these satellite farms that are down the road. They're the outpost farm. They're the neighbor's farm. That are under this shared management, but they're over there. So in the past, and that's why I took this, because Eric and Steve have not probably had to deal with this yet. The CNMP covered all of that unit that was under shared management, shared manure application, and all of those items. And we said, we're going to do them all. We're going to inventory them all. But you only need to implement on the main production site, and you had to meet the NR 151 prohibitions on the other pieces. No longer the case. So we're dealing with individual farmsteads themselves. The satellites stand on their own as separate farmsteads. If the landowner chooses and wants to incorporate it and make it one big package, they are free to do so. But from a contractual standpoint, they're individual farmstead locations. So hopefully that helps a little bit. Another question here about pre-planning meetings from the NRCS perspective. Who are we anticipating being at those meetings?
Sure. I think it's pretty, from the farmstead planning component portion, I think it's pretty important that we either get the NRCS area engineer or a field engineer or an experienced CET out there to discuss and collaborate a little bit on the level of investigation that's required to qualify existing waste storage and handling structures. So otherwise, you run the risk of evaluating those structures either half full of manure or not, or digging one pit or two pits and not deep enough, and then we end up with this back and forth between the plan preparation and the NRCS plan reviewer, and we're trying to cut down on that. I think it's in everyone's best interest to have the right NRCS technical representation out there to come to some decisions on what level of investigation is needed to qualify these structures. So.
Yeah, and I would add that every site is going to be different. So the staffs are always going to be different depending on the sites, and the knowledge of the people of the farm is definitely going to be the case. And with the modern technology we have, and especially over the last few months, as we have learned to rely on those more, a pre-planning meeting doesn't necessarily have to be all boots on the ground in the same place either. You know, a Zoom meeting, a Teams meeting, whatever, communication level that is, can be part of that. Steve wants to chime in a little.
Yeah, I just wanted to mention we had some discussions about this a little bit earlier, and we come to the conclusion that it's probably a good idea if the CNMP planner and the engineer, the PE involved from the consultant's point of view, take some time to maybe do a site visit, pull some of the maps together, and dig in a little bit before we have the pre-planning meeting. Otherwise you're kind of meeting out there blind for the first time and trying to cover an awful lot of ground, and you're most likely going to miss something and waste everyone's time. So I think we kind of come to the conclusion it'd be good if at least the PE, the consultant, kind of grind away on it just a little bit, and then pull an NRCS technical staff out there to come to some definitive conclusions about what needs to be investigated and to what level. So.
Okay, I have one here that didn't get typed in, but it's something that popped into my brain as Eric was talking about these plans talking to each other and writing the plan. So I'll give you a little bit of a background, then I'll have you chew on it a little bit. So in our TSP world, at the moment, a number of years back, we switched and we have one plan writer. It is the TSP of record. The one we're contracting is hiring a TSP to get paid to do the plan. So my question to Eric and Steve is, who is ultimately responsible, since we only have one certification or one TSP at this point?
Well, ultimately, the person who's responsible for that plan is the producer, the owner and the operator. They're the person who's going to be signing off that. That's why it's important to keep them engaged. But the reality is we understand that we've got a person with specialized skills that's been brought in, and this is absolutely necessary for this because of the complexity of this planning, and they bear a huge amount of responsibility. So the overall planner that you just described would be the person who has to make sure that if there are people who are doing pieces of that plan separately, that any of the information that needs to be included as part of an iterative process, and this is usually a problem when you're dealing with a land-based, which is running up onto the edge of having enough land there for the number of animal units that are involved. Make sure that those communications are kept as a part of that, and to go back and check so that any reviewer that might look at that, or in the worst case scenario, a facility gets built and all of a sudden you get to a month of the year when I'm thinking of, and this was before it got built, caught this at the end of February, and there was no place to put the manure. So those sorts of things have to be the responsibility of someone, and that's why I think that the TSP, the person you just stated there, would be ultimately responsible. Steve, anything to add?
No, I guess the signature page has 3 signatures on it. So at the end of the day, we need a certification from those 3 parties to validate the CNMP. So the owner, the CNMP planner, and the PE. So NRCS wouldn't accept anything with 2 out of the 3 signatures. So
Okay, take yourself off of mute before you talk, dummy. So there are a couple other questions that floated in that are definitely going to be covered in the next couple weeks. One is related to CPA 52s. It was a big push with our previous state conservationists that the TSPs were going to be completing CPA 52s. There's been lots of policy debates back and forth of yes, no, and whatever. And as Eric said, the consultants, the TSPs are providing the data for the CPA 52s. And we, NRCS folks, are actually going to be putting it on the paper and completing them. So, and we'll get into that more next week. Doug, I saw yours, and Jay, I saw your reply. I'm going to not even touch that. You guys communicated, and again, more next week. So I guess we'll open it up to, well, let's finish up the last couple slides here, just announcing a few things, and then we can do the unmuting Penny, and we can get to live questions if people have them. I'll take these. So for the engineers out there, with staff changing here at the state office and administrative assistants leaving us, getting things out sometimes is hard. So while we had you, just note that our Wisconsin construction spec 3 has changed slightly. The national specification for earthwork changed. So we updated our spec for earthwork, which led to some changes with concrete and backfilling near freshly placed concrete and structures. So take a peek at that a little bit. And since Steve has been here, we've been working on updating the Engineering Field Handbook Chapter 4 Exhibit A, which was the logging of soils and things along those lines. We've added a larger component into it for geotechnical investigations for bearing pressure and foundations for buildings and walls and structures. So that is new. We probably need to have a webinar just talking through a lot of that, but be aware it's out there. Take some reading of it, understanding what's there, so we can have a discussion sometime and present that with some questions back and forth. Penny's been chiming in here with information in the chat room, but the next 2 Wednesdays, again, are continuation of discussion. There is the link. If you have other colleagues who'd like to get in, they can register for just these pieces that are coming up in the next few weeks. You got problems with registration, get a hold of Penny or myself, and we can figure out what we need to do. So the next couple weeks, here's where we're headed, filling in a little bit more of the puzzles to this background. And that is the end. So any questions? Penny, how do you want to handle that?
I'd say just whoever wants to talk, just try to get in and we'll take them as we can.
yeah, I did want to just mention one thing that it relates to what Eric Hurley had mentioned, that the components of this CNMP kind of have to interact with each other. We did have some concerns on NRCS part that some of these CNMPs that come in the engineers are sizing for, the minimum 6-month storage or 12-month storage without communicating well with the land or with the nutrient management planners. The timing and application of manure and the crop rotations out there are a big deal, and they largely drive the amount of storage. It really should be a two-way communication. It shouldn't be the engineers planning a storage structure and then painting the nutrient management planners into a corners trying to figure out where to put that manure. It should be a little bit both ways. So I just kind of wanted to throw out, kind of a flag to the engineers that, you're not just designing for the minimum storage requirements required by the CAFO regulations or what may be interpreted in NRCS standards. It's actually a communication between nutrient management and the landowner, and what storage best fits the operation. So,
Penny, I see no other hands up in the room, so I think we are done for the day.
We are done. Well, thank you, everybody. Thanks, Scott, for keeping things going, watching the chat line and helping us through this, and Eric and Steve for the great presentation. And I hope everyone has a great afternoon. Okay, stay well. Thank you.